Welcome back to Dr. Liu's VCE Physics. Today's topic is magnetic flux and Lenz's rules, as presented in the 2024 VCE Physics exam. Let's learn together. If teachers, parents, or students notice mistakes in my explanations, please provide me with your feedback. Faraday's law tells us that the induced current is directly related to how quickly the magnetic flux changes. In the first stage, a constant induced current means the magnetic flux must be changing at a steady rate. If you were to graph this, it would appear as a straight line. Next, in the second stage, the induced current is still constant, but it's at a higher value. This indicates the magnetic flux is still changing linearly, but it's doing so more rapidly, making its line steeper than the first stage's line. Finally, in the third stage, the induced current returns to its original value, becoming constant again. This means the magnetic flux is changing at the same rate as the first stage, so its line would be parallel to the line of the first stage. According to Lenz's law, an induced current will generate a magnetic field that opposes the change in the original magnetic field passing through a coil. In this scenario, as the coil moves upward, it encounters a decreasing upward magnetic flux. Therefore, to re-establish an increasing upward flux within the coil, an anticlockwise current must be induced. The split ring commutator produces a rectified sine wave, which is then delivered to the oscilloscope. Although the voltage value varies, it consistently flows in one direction, thus qualifying it as a DC voltage. The apparatus uses a single coil of wire in a uniform magnetic field, linked to slip rings X and Y. The essential role of these slip rings is to provide uninterrupted contact with the spinning loop, facilitating the transfer of the generated current to the oscilloscope. The signal exhibits an 8V peak-to-peak voltage. Its period is 0.2 seconds, meaning its frequency is 5 Hz, as frequency is the reciprocal of the period. We've modified the apparatus, and the solid lines now show the new results, with the original voltage still visible as a dotted line. Notice that the new readings, solid lines, maintain the same period, but show a doubled peak voltage. To achieve this, we could have doubled the number of turns in the coil, doubled the magnetic field strength, or doubled the loop's area. Each of these changes is consistent with Faraday's law, which explains why they would lead to a doubled peak voltage. Accounting for 10 of the total 120 assessment marks, 8.3% of the assessment, the magnetic flux and Lenz's rules section consists of 3 multiple-choice questions worth 3 marks, and 1 short-answer question worth 7 marks. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.